Thank you, Sylvia, for the opportunity. I would love to thank today's session. However, what I just did understand, okay, I came in late, is he kept referring to utility, and I think I didn't get that. But I love the fact that he has well articulated the criteria for assessing theories, because in most cases, especially when you're starting on your PhD journey, they are telling you have to choose theories, you have to theorize, and people don't understand.
Okay. Thank you, Dorcas. I think the concept
why you must choose a theory, or must integrate the theories.
Hello, Dorcas.
Thank you.
I see. Okay, my network has been breaking. I lost you at some point, but thank you for sharing your experience. The issue of utility, I think the professor was just referring to the usefulness, applicability, like criteria for assessing the usefulness of a theory. So it didn't really mean a big issue in there. It's just a word in this context. So is your theory useful? Is your theory applicable? Does it really work with the reality? It's just a word, usefulness of a theory. Yeah, thank you very much. I don't know if we can still give a chance to another person, given that Dr. Walgembe is already in. Can I just hear from one gentleman? I think Bob, you have just been through this aspect of theory building. Is it possible to hear your experience?
Yes. Good morning, and good morning, fellow students, professors, and doctors. Maybe something that I've also captured here, in addition to theory, is that he has mentioned that as you are trying to come up with theory, please do not forget about the philosophical orientation, because at the end, as you're choosing the theory, somehow, somewhere, the philosophical orientation must also come out. He also mentioned about that as you are choosing these theories, should be in position to choose those theories that demonstrate that they stand test of time. So, and as he was explaining the different components, I think he mentioned it, and the types, that it is very important for us to choose those theories that have demonstrated a stand of test in time. Thank you.
Okay, thank you very much, Bob. Finally, I want to give Thomas a chance before we close and we move into the next session. Thomas, would you like to say something? Mayende Thomas? All right, I think Thomas is not able to communicate. Members, I want to thank you. What I can only urge us is to try to reflect what we have just, gone through in relation to your work. Look at your study critically. Try to see what kind is your theory speaking to your study. Does your theory meet all these criteria that today we have heard about? And is your theory useful? Will it stand a test of time? Does it communicate or capture the philosophical stance that you are trying to use? Yeah, so let us reflect, and then we shall get back together in the next session to continue with the theory building lectures. Yes, Dr. Walgembe, I would like to hand over to you so that you can take on with the next session. Thank you very much.
Thank you very much, Livia, for really standing in for the team and being able to do a great job. Thank you for coordinating the first session. And I think our colleagues or members are able to pick something from the theory building sessions. Right. As we move from theory building, we cross to the main session, and I would like to welcome all of you to our main session this morning. I would like to appreciate all of you for joining in time and the normal commitment for being on time in the sessions. This morning, we are hosting again our own Dr. Nkurunziza Gideon, and we are going to start from where we ended last week on really moving ahead in unpacking regression. However, before we go to that point, allow me recognize the members on this platform and also appreciate the senior colleagues who were able to wake up every morning to support others move ahead. And let me start with our own. Professor Joseph Funtai, for the commitment to support students grow, for the sacrifice he has given in supervising students, for the time he has given in to develop content and support students. That selflessness is really what is required at this level. Professor, we welcome you and we thank you for that wonderful commitment. Allow me, I'll appreciate my own colleague, Associate Professor Michael Okoche. So Michael Okoche, we moderate together these sessions, and for over the years, he has been the main person in moderating and managing the sessions. Professor Okoche, we welcome you and we thank you for that commitment. Allow me also appreciate and welcome Dr. Edith Mavasalirwa as a senior colleague on the platform, always log on and also supporting the commitment. Then Dr. Gorit Sheune, thank you very much, our own, for your contribution to the sessions and also your support. Always. Dr. Msenze, Dr. Msenze has been here giving so many number of presentations, and we appreciate him being one of the core team that actually manages the sessions despite the busy schedules. All the members I'm talking about have very tight schedules, and among the very tight, Dr. Msenze has very, very tight schedules, but he manages to log on and supports the move. And our own Professor Rola Orobia. Professor Rola Orobia, thank you very much, our own professor. We normally call her the first female professor. Professor Rola, thank you for being available and supporting the students community. And then Professor Sam Aderamora. Professor Sam from Norway, but currently is in Uganda, but he has been online ever since, whether from Norway or from here. He always tries as much as possible to make the platform really a global platform, international platform. So we appreciate you, Professor Sam. I think your presence here in a discussion on statistics, especially on regressions, will make it more meaningful, and hopefully shall be able to get your contributions to the students. Allow me appreciate also the students community. I mean, the senior students who have really been able to support this platform. Many of you have done a great job, but allow me specifically I appreciate those who normally moderate the first session. Sylvia, thank you for today's session. Thank you very much. My colleague Joseph Elasso is not here, but he normally does a great job. And also colleague Amerit John Bosco, we thank you very much for that support. Bosco, thank you very much. Bernard Wabkala, we appreciate you, and others. And we encourage you for the first session, please link up with Joseph and make sure that we have the session running. Anybody on the platform now, especially those who have been here for 2 years plus, you should be able to support the other colleagues to ensure that this platform moves on well. With those few introductions, for the new ones, this is a global platform, and we normally say that this platform is there to support all students, whether in East Africa, South Africa, North Africa, in Europe, Asia, in America, and we welcome all of them because it's a learning group. It's a learning group, and we are ready to continuously support the learning processes. Allow me, in those 3 remarks, I'm going into our today's session by inviting our own Dr. Gideon Kurunziza to allow him again unpack the issue of regression. And last time we dealt with correlation and regression interpretation. Today, Dr. Gideon is going to help us also look at issues of interpreting regression results, but specifically, today he wants to focus on recursive and non-recursive regression models. And our expectation is that we should be able also today to understand and appreciate the concept of endogeneity and how to deal with endogeneity in interpreting results and managing data. So Dr. Gideon is a senior lecturer at Makerere University Business School and currently is the head department of education at Makerere University Business School. However, his background is in statistics and in education, and is a very good statistician. I love him for that. Allow me to welcome him and share with the audience. Dr. Gideon, you can now share your screen, unmute and share your screen. And thank you for also being with us. Thank you.
Yeah, thank you. Thank you, Chair. Thank you for the remarks, and I would also take the chance to welcome each of us in your respective capacities, particularly senior mentors, our senior mentor, Professor Tai, and the rest of the mentors, the scholars, the students from Uganda and other parts of the world. You are welcome. As the chair has mentioned, we are building from where we stopped. Chair, as I proceed, may I confirm whether you are getting me?
Yes, you are clear, and the slide is also clear.
Okay, thank you very much. Last time we looked at the correlation and regression, but as we proceeded, our major focus was looking at one specific kind of model that you pay attention to, looking at one direction. Looking at one direction, we did not look at the two-way causal effect. In this context, as I make this presentation, it is important to know that each of us have where we come from. There are those who come from economics, There are those who come from social sciences. There are those who come from natural sciences. And so, as we have this discussion, I request each of us to reflect what kind of models do we usually look at in our area of research interests. I know this debate used to be very common in economics and natural sciences, especially when they're doing experiments using longitudinal studies, use of panel data, time series data. But today, the debate is going into other fields like social sciences. And indeed, I want to say this may sound to be new, but it's not new. When we talk about recursive models, here our interest is to look at when you are conceptualizing, for example, what is the direction of those arrows? Do they make sense? If you are looking at dependent variable and other predictors, do you look at the direction of the arrows and what is the message as you theorize? Now, there's where you find that the predictor variable can end up being predicted. So you find that there is a feedback loop. When you have feedback loop, that is where we talk about non-recursive. Model, we know what a model is. It is something that presents reality. And in research, we develop different models. We try to conceptualize and we develop either from where you're coming from again, the lens you use, either you use a conceptual model, you use a mathematical model, others develop analog models, especially those who come from computer science. So basically, today's topic, we are concerned with causal models. But causal models in line of regression analysis. Now, when we talk about causal models, of course, the assumption again here, you need to pay attention to the search design you are using. At times, most of the studies focus on associations. But I am aware that there are other studies that look at causation. So as we talk about causation, then you find that we have to pay attention about what kind of models are we talking about. Is it recursive? Is it non-recursive? What are recursive models? Recursive models, these are models which are unidirectional. They have one direction. Now, when you are conceptualizing, you need to understand the context under which these processes, in other words, the way you are trying to show how the predictors are influencing the dependent variable or the response variable. And the other one you find that which you must pay attention is about disturbances. These disturbances are what you call the error terms. Now, the error terms for the predictor variables should not be correlated with the error term of the dependent variable. This is mostly common, especially when you're running structured equation models. When you're using EMOS, when you're using partial least squares, even when you're using views and other models like other programming, you need to pay attention to these two major criteria that guides you to know whether you are having a recursive model. But of course, this is at the point of analysis. Don't forget that this again comes from the way you have conceptualized. And your conceptualization is guided by the theory and empirical studies. And that perspective, there is also the understanding of priori. What knowledge do we know? If we are coming from economics, there are those aspects that really you must pay attention to, which may bring your model to become a non-recursive, not recursive. So I know most studies look at path models that are in one direction, but we know there are also other models that look at the two-way causation. They have two-way causal effects. We actually call them, those effects are called reciprocal causation effects, or what we call the feedback loops. So in other words, you find that if you are talking about recursive models, by illustration, I have this simple kind of illustration. And with due respect, today I tried to avoid touching figures, so that then it should be a general presentation to all of us to understand specifically the message behind these models. If you look at this illustration here, you have x1, x2, x3, x4. These, of course, in modeling, what are these trying to represent? These are representing different independent variables. And these independent variables are predicting, or they are causing a change in y. Now, when you look at x1, it's predicting x2. And x2 is also predicting y. Now, when x1 predicts x2, we have an error term. For those who are familiar with structural equation modeling, this is very clear. It can easily be generated, and you see those error terms being very critical. Now, then you find that these x2, x3, and x4, these are also predictors, but you find perhaps there is no relationship they have with the x1. But this depends on how you are theorizing. If the theory does not show that x2 is a mediator, then you may not have that arrow of x1 leading to x2. Now, what is the message here? The message is that when you look at this model, the arrows are going in one direction. We have unidirectional effect, causal effect. Two, when you look at the error terms, E1 and E2, they are not correlated. If they are correlated, I would have an arrow. I would have an arrow that comes from E1 to E2, the error 1 and error 2. E1 is not E times 1, it is E subscript subscript 1, and the E2 is subscript 2. Now, which means when you have a model which replicates this kind of illustration that I'm giving, you know that satisfies the properties of a recursive model. Now, we also have the non-recursive models. For example, here, we have the independent variables x1, x2, x3, and x2, and the dependent variable is y. Now, when you look at the x4 is affecting x2, and at that point we have an error term. Then x2 is affecting y. At the same time, y is affecting x2. Now, in real life, I think you can have, when you're conceptualizing, as you read and you see the way the debate is going and you see the missing links, you actually come up with a hypothesis, which may actually be showing that x2 affects y, at the same time y affects x2. Now, when such a situation happens, we shall see the implication later about the aspect of endogeneity. There must be a reason why such a kind of mechanism occurs in your model. But the point I'm trying to arrive is that you can see, when you see such a kind of regressions, you know that is recursive model, and you must be able to know how do you handle such a kind of models which are taking two-way causation. The feedback loops, you can see, is in two directions. At the same time, you can see that E1 and E2, the error term 1 and error term 2, again, they are being correlated. Now, maybe I need to say, what does error term mean? If you look at E1, what does it mean? It means that you have looked at all these predictors. As you conceptualize, you had a number of predictors. You have a number of independent variables. But when all these independent variables explain why, there's certain percentage, there's a certain value that is not explained by all these. Now, that value that is not explained is explained by other factors. And those other factors are the ones that give rise to this error term, which is E1. And that's why, to some extent, when it comes to interpretation results, don't ignore the value of error term. It communicates something. And perhaps when it's such a kind of variations where you have the two-way causality effect, then you may find there is a certain variable that you did not look at. As we continue, we shall see how to handle such kind of situation. But as we proceed, we need to be mindful about, again, what guides us to know that this is recursive and this is non-recursive. For non-recursive, we are saying disturbances you find they are correlated. These are error terms now. For the predictor variable, it could be one of the predictor variables, or it could be more than one of predictor variables having the error term correlated with the error term for the response variable or for the dependent variable. And the other one is a situation where you have the feedback loop effect, the two-way causal effect. So this kind of model, when you are trying to use it to make a prediction, it is in most cases, actually it is inconsistent and biased. When you just try to predict and you ignore, you predict as if it is, you use it as if it is a recursive model, you are likely to have the biased results, and which are not consistent. Not consistent means you are not actually measuring, you are not explaining what you wanted to explain, which is your criterion variable. The other one, if you look at this model, for example, you find some people actually, they have different variables. You find you have x. This x is a predictor variable which has got components x1, x2. At this moment, for those who have already conceptualized or you are familiar with the conceptualization, when you operationalize a variable like x, maybe it could be x could be employee engagement. When you operationalize, you have vigor, dedication, absorption. Now, if you consider two measures or components, which you call x1, x2, then you can see how they're explaining x. But when you look at this one again, this model, x predicts y, at the same time y predicts x. And then when you look at this one, this model again, it has some other hidden variables which we call instrumental variables. Now, we shall see when you talk about instrumental variable, what are the characteristics, what are the criteria for us to make them qualify as instrumental variable when it comes to endogeneity bias. Now, when you look at Z1 and Z2, these are some of the hidden kind of variables, which when you ignore them, they become an issue. But then when you look at the way now this model is, you can see that this model has a problem. It has a problem the way that the instrumental variables are not supposed to be related. They should not be significant predictors of y. Now you can also see the error term E1 for the predictor and the error term for the dependent variable again being correlated. When they are correlated, that's a problem. That is a problem. Now, these are situations where, in most cases, people run models, but when you critically look at them, you find that from the earlier conceptualization, somebody was not paying attention to these kind of effects, the two-way causation. But then when it comes to results, the results are showing exactly that what you have done is not right. And it's important here to pay attention to these aspects. I know when you run models, we celebrate and we say, yes, our models are explaining something, but you don't pay attention to these kind of non-recursive models. Chair, maybe as we explain, I'd not use a number of real life examples. If you look at X, for example, here, being a predictor, and Y being a dependent variable. Like in, I think, particularly what is happening in our economies, if you look at the earnings, almost everybody wants to spend in education such that we can have improved earnings. But I've also realized that for those also who complete, they also want to have increase in the earnings. That yes, I've finished, I have these papers, I need also to have increase in the earning. So you find that the education again and the level of and what you earn, the two tend to have some kind of causal effect. And this, if you now conceptualize and you leave it at that level, then you are likely to have a problem. Because ideally the theory, what the theory is saying, and what the data is saying, you will find some bit of divergence. And so it is important to harmonize the two. I know for those who use these models that where we have measurement models, and then we bring in the structure, and then we derive now the same model. I think it is important to appreciate some of these things, because these are very common issues that come in. You may actually find that the education is influencing the level of earning because of certain hidden variable, which is actually driving that. So in this kind of regard, it now brings us to another level where we now need to know why recursive models tend to exist most often, and why we shouldn't celebrate whenever we are dealing with recursive models. One of the issues which in most cases researchers don't pay attention to is endogeneity bias. I know most scholars, they explain common method bias, response bias, and others, but they don't usually talk about endogeneity bias. Even those who tend to talk about it, they give scanty kind of information. However, I believe that it is time for us not to ignore this, because whereas we talk about the path models, which we call recursive, stochastic, they are not usually recursive. In most cases, they are actually non-recursive. But because we don't want to go into endogeneity bias to test for it, we just take one direction, and yet the reality may not be true. I know most people want to reduce time complexity issues, and so they dodge that. But it is very, very critical. This can end up making your model inconsistent, and meaning that it may not be able to reflect the reality. You can't use it to make estimation. And that case, when the regression model collapses, and yet it's where you're going to derive your recommendation, the implication in most cases, this regression model is very, very important. So when you don't derive a good model that is fitting, that is reflecting the reality there, then it becomes a problem. And remember, statistics does not lie, but we can lie using statistics. We can lie using these models. As scholars, it is important that we pay attention to this bias. Now, what is it? And I want to explain a number of forms where we could have models, and these models are having issues of endogeneity bias. The first situation is when you correlate the error term of the response variable or of the dependent variable with the predictor variable. Now, when you correlate the error term, which I'm calling U, and we correlate it with X, which X is our predictor variable, and you find that the value you have got is significant, then you know there's a problem. And that is endogeneity bias. You have a problem. That reflects there's a presence of endogeneity issue. And it is important that you critical at an early stage, even if you are not the one who has analyzed, at least you must have that theory in mind to check the results and know whether you don't have that problem. The other situation is where you tend to omit certain variables. Ideally at conceptualization, and that's why in research, when a conceptualization is wrong, these issues usually emerge. When you exclude certain predictive variables, either because you have not used the right theory to explain the reality there, or the practical issue, or you have not read intensively the empirical, you have not reviewed literature empirically in your area where you want to contribute, at the same time, even in the other discipline, to understand how you can be able to conceptualize. So you end up excluding key variables. And when you exclude these key variables, then you'll have an issue. You may find that I'm just using one variable, which is for simplicity, X, which is a predictor, and Y. This is just like a simple, this is a simple regression, but you can have multiple regression where you have more than one predictor variables. But out of those, you find that even when you try to correlate, these things may not actually work. You find X is even failing to predict Y. But when you introduce a certain variable which you omitted, either because of some of the reasons I've mentioned, then you have that problem. You have the problem of endogeneity. And this is very common. It's very common. Some people, like for today, almost everybody wants to invest in different viable projects. Why do you want to invest? You want to increase some kind of returns. If X is now the investment decision that you make, and Y is the returns that you get out of those investments, at times you find that this may not necessarily the investment you make, this investment decision you make, may not necessarily improve the returns you get, or may not necessarily cause a positive change in the returns you get. It may be, maybe you could have considered the strategy that you have as a manager or as an investor. That strategy is now the hidden, the excluded kind of variable. The strategies you have, you make, could be the hidden kind of predictors. Now here I may not give a number of excluded factors. I think you need to know where we come from. Like for those who come from economics, even not necessarily economics, I think all of us, usually when you look at the unit of analysis, there are things you ignore. And somebody would want to say, but you have not included these characteristics, yet you are looking at the construct, which requires aggregation of data at organizational level. And somebody says, you left out the edge, maybe how long has this organization been in existence? What about the structures in terms of maybe the number of employees we have in different departments? Depending on what you're studying, there are certain things that you may not exclude, even the characteristics, organizational characteristics, or even individual characteristics, depending on the topic that you have. If you look at this, for example, for those who do economics, there are certain variables that you don't ignore. Economic shocks, those are very important. What about demographic aspects? There are things which sometimes may cause change in the predictor variables that you have as you make estimation of your model. And so pay attention to that, otherwise ignoring that variable which is important, which could be among the predictors, and ignore it, then it may lead to endogeneity bias. Now, the other one is what I mentioned earlier, that you tend to have the feedback loops. And this also causes a problem where you have inconsistency and biased model. And therefore, you need to pay attention to this. If you had enough time, maybe as part of discussion, each of us would give relevant examples where you find these kind of situations. However, I believe you are, wherever you are having that kind of illustration, either in your mind or somewhere where you're writing. It is important to know what in the study you're having. Do you have those variables where you find one affects the other, where you have the two-way causality effect? And when such situations arise, do you know what it means? It means that you have endogeneity. So, what could be the causes? I think I've mentioned some of them. One, some of the causes could be you have an issue of reverse causality. And of course, when you look at these models we use, especially the SEM, which involves simultaneous, multiple regressions, those are plausible to these issues. So whenever you run the same, be mindful about some of the issues of endogeneity. Other issues are measurement errors. At times, we must pay attention to this. The measurement errors, there are many causes of measurement errors. At times, even a wrong estimation of sample size is questionable. At times when we use smaller samples and we are using the models that don't consider the issues of measurement errors. And I think this sometimes explains why, for those smaller samples, tend to use partial least square, because it gives the computed values of those, it takes care of some of these measurement errors, which is contrary to Amos. Now, but these are issues. Measurement errors reflect on how you are measuring the variables. At times, that can lead to endogeneity bias. Yeah, omitted values, yes. Unobserved values, I mean unobserved variables. Let me use the word variables because we are looking at these predictors which change over time. Now, this is where, when I say unobserved, this is where when you look at the error term, be mindful about this value, otherwise you may find there are unobserved variables which you are not considering, and they are taken care of that error and the problem. So be mindful about that. In term series, we also talk about the lag dependent variable issues. So there's also endogeneity in that regard, and it is important to look at that. There's also this one, the selection biases. Sometimes you have you are fitting a model until it fails, undefined. It is undefined. It's not well defined. Why? Because there's a certain variable that is missing. At times when you are fitting a model, especially for those who use the same models, fitting the model may be a problem because you have the issues of endogeneity. Now, the remedies are not easy as we think because at times even eliminating measurement errors is a problem. But when you start from the word go, as you conceptualize, then you go through the item response theory, where you do EFA, then you exploit factor analysis, and then you go to confirmatory factor analysis, perhaps, and then you reflect on the other previous scholars, what they have used to measure. Perhaps you can somehow reduce them. I'm saying somehow because at times measurement errors tend to be a little bit challenging, tend to be inherent, but you tend to minimize. It's about minimizing, it's very hard to do away without errors. Introducing omitted or unobserved variables again, this is when you keep on having critical eye at every stage. And you know what the results are saying, and also what the scholars are saying. Always keep reading, keep updating the debate in the line of theorization, in the line of hypothesis development. The issue of narrowing generability, I think this is also very important. That's why the question of which statistical package do you use what were the sampling, design and procedures? Did you follow that clearly, systematically, articulately, accurately? And of course, that has implications both. And even when you do exploratory factor analysis, the sampling adequacy must be telling you something, that there's a problem somewhere with the measures that you used. So I think this can also help. Now, for today, I just want to emphasize on one of the statistical measures that one can use to handle endogeneity issues, and that is the two-stage least square method, two-stage least square approach, which is done by introducing an instrumental variable. Now, as I said, you need to know where you're coming from. You need to know what is known there. What do we call those instrumental variables? What are those likely hidden variables that you must not ignore, which in most cases sometimes we call them control variables. Those can be very, very important to help you deal with endogeneity bias. Now, as of course procedurally, if you are to do it of course using the statistical approach, what do I mean? You need to do what I have earlier said, that you need to check the error term first and see whether the error term for the predictor is correlating with the error term for the response variable. I know, whereas you can easily be able to estimate the beta value, which is the marginal or slope parameter that allows you to explain y with the predictor x. At times, whereas you may rely on that value, it's not enough. You need to check the errors. If now you find that the two errors are correlating, then endogeneity exists. But when it is not, then you know that is not a serious issue. Endogeneity issue is not there. Now, but of course you also need to look at the other scenarios I've mentioned as well. But this one helps us, especially when you are going to use the statistical approach. Still, you have to go by the guidance of the approach that you have decided to use. Now, so in this case, introduce, for example, I have two variables here before I introduced z. X1 is the predictor variable, which is the independent variable, and y is the dependent variable. Now, you are trying to see what variation perhaps that is explained by x1, variation in y, which is explained by x1, and you realize that because there is endogeneity, you have to introduce the third variable. This third variable is what we call instrumental variable. And there are certain characteristics or certain criteria, certain procedures that you must follow. You don't simply introduce the instrumental variable. You must be able to check whether it satisfies certain criteria. One of the criteria that you consider is this instrumental variable must be correlated with the predictor variable. In this case, I have x1 and x2. Ladies and gentlemen, I would be using actually the real variables, but since I'm talking about modeling, I know X can take different predictor variables. It represents predictor variables. So depending on what value we want to use, which is a predictor variable, you can still substitute that there. If, for example, I'm talking about like the other previous example we used, we talked about the shipping price and the distance covered. If x1 the distance covered and y is the shipping price, the distance covered determines the value or the change in the price. Then it means we could find that maybe there could be something that could perhaps be included in this model to make X become more powerful in explaining Y. And that is the instrumental variable Z. So I've said that when you correlate X, or I don't want to use these words, correlation, covariance, but let me use the common one. When you correlating is just establishing the association or the relationship depending on the design you are using. The association between X and Z, which is the predictor variable, and the instrumental variable which you introduce. This instrumental variable can be even from the control variables. Now, when you now correlate and you find that the value you are getting is significant, it's not equal to 0. If it's not equal to 0, that means this instrumental variable is relevant. It means it is applicable. Then the other one, you ensure that again when you correlate the instrumental variable with the error term of the dependent variable, when you correlate the two, and you find it is equal to 0, then it means it's okay. Yes, it means it's fine. It is good for you to proceed and take this Z as instrumental variable in your model. So this is the simplest way of how you can investigate the need to introduce a control variable and to check whether that instrumental variable, whether it is very important to reduce the endogeneity bias. Now, at times, it's advisable that you don't look at only one instrumental variable. You can look at as many as possible, depending on the context of the study, depending on what the scholars are saying, that these could be the probable ones. And as you conceptualized, you came up with a conceptual model, you found that these are really critical to cause endogeneity. And therefore, in other words, that if they miss, if they are not there, you'll have endogeneity issues. So those are what we call instrumental variables. So the two-stage model, this square model that we use to solve the issue of heterogeneity. Of course, this means when you want to use the two-stage least squares, you must know the steps involved to investigate that, or to minimize the endogeneity issue. The first stage, Of course, having identified your instrumental variables and sometimes the exogenous variables in the model, then you have to obtain the predicted values of the heterogeneity variable. Of course, when you find that that independent variable becoming having an issue of endogeneity, we usually call it endogenous regressor. In most cases, that's the term we use. But as we look at that, when you now regress, you regress endogenous variable, that variable which was earlier predicting y with the instrumental variable, if it is one or more than one, then you obtain predicted values of endogenous variable. Now, in this case, this is where we tend to use some, of course, if the earlier exogenous variable was x, here I use x cap, but I don't want to go in that because it may sound as if it is a hard thing, but it's not hard. I'm trying to say that when you now regress endogenous variable, in this case, endogenous variable could be our x1. We regress it with z, which z is the instrumental variable. What we get is the predicted values. Now, it means you have created another variable now. When you get predicted values, definitely you have to save those results in the software. If you're using spaces, you can save them. And then, in the next stage, you now regress the original values of y, which is the criterion variable, or which is the response variable, or the dependent variable, on the predicted values, which now the values we got in stage 1 are the ones that actually use again to regress on, use them to predict the y in the model. Now, of course, having got that, then you can now compare. You can compare the symmetric coefficients on the predicted values of indigenous variable and see whether they are the same as when you enter the instrumental variable, the criterion variable, and the endogenous variable in the model using the two-stage least squares. And I think this, I may do it now practically to see exactly what I'm trying to communicate. So when you have done that, definitely means that like other models people have been using, most of them don't introduce instrumental variables, and at times when you don't introduce them, then if the model has endogeneity bias, it keeps on being there, making the regression model inconsistent. And if it is consistent, then it means that it's not good enough to use it to make prediction. Now, before I go to that, I want to mention this, that that as we look at ordinary least squares, definitely we use them. Of course, we use the ordinary least square to make prediction. So once we go to ordinary least squares, especially the one what we did last time, we're able to learn the simple and multiple regression and understand whether the mode is fitting, looking at a statistic, looking at even the beta values, looking at the marginal parameters of each of the predictor variables, as well as understanding the contribution or the predictive power of each of the predictor variables, as well as when looking at all of them on the dependent variables. That one we have done that, but in most cases, as you do this, then pay attention to those non-recursive issues, which sometimes actually which are mostly brought by the endogeneity issues. Or if it's not endogeneity, then it means that theoretically that's how it is. Ideally, you may find there's two-way causality, but it doesn't necessarily mean it's endogeneity. It could be maybe how the theory is also explaining that. So it happens in complex situations. So the others is you could have indirect least squares issues. When you're dealing, of course, with the simultaneous equation models, like structural fusion modeling, you'll find if you're testing for mediation issues, all that, it is important to pay attention to such issues. And the two-stage is where I am going to now do some kind of illustration on, of course, handling the issues of endogeneity. If you suspect the endogeneity issues, then two-stage least square is very, very important, because you have to introduce instrumental variable in the first stage, and then you get the predicted variables, which you can still use as now to represent a predictor value, which has taken care of the other issues by introducing the instrumental variable. And then you get the final model, which you can now use for prediction, or for drawing conclusion, or for making kind of decision in line of the purpose of your study. I think that's important. So let's look at the two-stage least square analysis. I think we can still use the same data we had last time, on assumption that we are going to consider maybe one of them to be an instrumental variable. Now, initially, as we conceptualized, we had said the shipping price in million is determined by the distance covered when you are shipping these, maybe the supplies, and then the delivery time and the mass of what you are delivering. Now, we do not consider the day. Maybe if we consider delivery time affecting or causing the change in the shipping price, you may find that if we ignore the day when the delivery is being made, it could be an issue. It could be an issue. Why? Some days you find that there are specific days where the weather is not fine, or the situation is not fine, where you have spillover effects, especially the traffic jam, depending on a number of operations on different days. Now, if I use this kind of assumption, then I take the day as instrumental variable. But of course, I know this kind of explanation is to help us enrich our research. I believe, as I explained this, you must be reflecting on a certain study that you're having, and you must be looking at what is the predictor variable. You must be looking at what is the dependent variable. You must be looking at what do you think can act as a instrumental variable in your study. I know to some discipline it is obvious. Some of those instrumental variables are known. In most cases, they are known. But also other disciplines where you find that where you deal with latent variables, most cases, it means you have to read further and you discover them. However, they are there. In every study, you need to pay attention to them. So for me, I am going to now assume that the day here is going to act as our instrumental variable. If the instrumental variable is supposed to be Z, we call it Z. These ones will be X1, X2, X3. Now here I have Z. If, for example, also anticipate that the distance covered could act as the instrumental variable, I can also consider it. And these other ones now I consider them as some of, if I find that, for example, X1 also can directly affect X2, but again this distance covered is not again correlated, is not significant, is not having significant correlation with the dependent variable. So if to satisfy those other two conditions that we mentioned about what instrumental variable should have, where we said that choosing an instrumental variable, it must be highly correlated with one of the predictors, which you call endogenous regressor, which have identified that yes, these two, whereas it is not there, it is not so much emphasized. We have seen it is very, very important. It can be the source of endogeneity. Then you choose that. Then the other assumption that instrumental variable, we said again, it should also not be correlated with the other term of the predictor, of the dependent variable. I think we said that. So that's very important. So in this case, we can use two-stage approach of the two square approach to this square approach. Now, two-stage least square approach, in this case, we can now start with, when we go to analyze, we can go to regression. Now, when you go to regression, let's first actually see if we use the two-stage, everything's there. We have the two-stage here. We have it here. Now, in this case, Chair, are we observing this?
Yes, we are.
Okay, thank you. So in this case, when we have identified the instrumental variable, then we can substitute directly. Now, in my case, I've said that whereas I have known that the distance covered, delivery time, and the mass of the supplies that I am delivering can affect the shipping price. I've also said perhaps if I pick one of them, I pick, for example, the assuming I'm having just two, I'm having the one, let me just use the simple regression, for example. Assuming in my data I'm having now the delivery time, which is my x2, and the shipping price, and I anticipated the day in my data which I had captured is important. It could also affect, it can actually directly affect the delivery time. That delivery time again should be well highly correlated with the day when I'm making deliveries. So I can find that there could be endogeneity because I've ignored the day in my model. So in this case, I will just consider I will just consider the day to be the instrumental variable, and then my shipping price is my dependent variable, and then when it comes to delivery time becomes my explanatory variable. Now in this case, I can now be able to run the model and I see what happens. Of course, I need to have these predicted values, and then if I click OK, of course it will ask me whether I want to save all of these two variables which have been created. I think the answer is yes, I can save them. When I save them, of course the outputs are hidden. I can share them now. I hope they are here. When I have this, then to me that this can be the model that I may use to make prediction. Now, remember the adjusted R, that's a contribution that these other predictors are making in your model. Because if somebody suspects that there is a variable that you ignored that is very important, which could be the source of endogeneity, and have considered it, then I think this model now will be more consistent because you considered that instrumental variable, which you think perhaps would be a solution for the endogeneity issues. Now for the coefficients, the coefficients, again, I think we can see the constant is 15.02002. Delivery time in hours, the beta value, I'm looking at the beta value, and standardized beta value is 15. This one is 0.802. Now this one gives the answer, gives the model direct. It gives the model direct, and you find that you can get the final model once you have identified the instrumental variable. However, if we go by what we said, using the two-staged model, I'm sure we could have this same kind of coefficients. Although the sig level may also vary, it may not, but for us to know that the two methods are the same, are giving us the same, because you can use the other one I mentioned, the two-stage kind of approach, you can still get the same answer. Let's also go through it and see whether our beta values will be the same. Now, so we can still go back to our data. When you go back to our data now, I'm going to use the two-staged without directly substituting in the already inbuilt system. Now here we have said the first step is to ensure that we regress. We regress, first of all, the instrumental variable with the predictor variable, which we think it is an endogenous regressor, and for us we have chosen the delivery time to be our endogenous regressor. Now in this case, we can now go to analyze, and then we use the least square. Sorry, let me first put this thing stabbing me. Then we use the linear regression. We go to linear. When we go to linear, now we have said that our dependent variable will be this delivery time, and in this case our independent is the z which we call the instrumental variable, and then we have to save unstandardized predicted values, and we can also look at residue. It's not major. What is major here is the predicted values. Now, when we finish that, we can now click OK. When we click OK, then it means, if I go back to data, it means that I have, in the data which I have here, Chair, are you seeing the data, or which one are you seeing? Or the outputs?
Not yet. The outputs are not there.
Oh, okay. Okay, the outputs we have got in the second. I hope you are seeing it.
Yes.
Yeah, in the second, they are not the final. This first step has helped me to get the predicted values. And these are more, when you use predicted values, they are more they are more, in other words, these are the more values that you can use for making estimation. Now in this case, I need to go to the data. When I go to data, now I will see that column for the predicted values. You can see here, this is a predicted value which I've created by regressing the instrumental variable and the predictor variable, which is our endogenous regressor variable. Now in this case, I can now go to the final stage, which is the second stage, and then I'll be able to go to call regression. Then from here, I now remove. I can even reset. We can reset it now. By resetting, what I'm interested in now is now to bring the original values of the dependent variable, which is now the shipping price, and then I'll be able to bring in now the unstandardized predicted values. Now these unstandardized predicted values, I was able to obtain them after regressing the instrumental variable with the predictor variable, which predictor variable was what? Was the delivery time. I said that if you consider delivery time and ignored the day, which day would have, if you left it, would have been the source of the endogeneity. I think this is why I'm now able to get and standardized predicted values now. I think we need to know where it has come from, and I think that's the major kind of new idea that one must pick. Then the next step is now having those and standardized predicted values. Then they are the ones that now use to become your independent variable, and then this one becomes the original now dependent variable, which you originally wanted to predict is what comes as the dependent variable as the final stage. And so we can even click OK, because these other ones are already covered. Now in our final model, we need to see what we have. Now, because the two methods must give the same beta values, if you use the first one, still is okay, and if you use the second one, still is fine. Now, excuse me, in the last model, which is our final stage, you look at the coefficients, you can see that the constant is having 15.002, and the unstandardized predicted value is 0.802. Chair, with your guidance, are you able to see these values?
No, we don't have the output.
Oh, sorry. Can you see them?
Yes, they are on now.
Okay, now this is what we have got in the final model. In the final model, you see the constant is 15.002. The predicted value is 0.802. Remember, we have used two methods. What I'm trying to do is to confirm whether the beta values are the same. What I'm sure of course, the significant levels may vary, but what happens is that I want to see the slope or marginal parameter whether it is the same, because that's the criteria that I'm looking for. Now, in this case, when you look at this, you have 15.02, this 0.8. Now, you can compare with the first one. In the first one, if I click on the first one here, and I look at again and standardized beta values, what do I have? The coefficients. You can see here we had 15.002, and this was for the delivery time was 0.802. Now, when you look at this value, you compare with this other one, the values are the same. Now, this explains that whichever method you pick, we adopt or we follow, can still give us the central argument or the message that we are looking for. So I think basically this is what means by using the two-stage least square analysis. And I've said why we need to use it is in a situation where we have recursive models, and those recursive models, in most cases, we are always worried by the issues of endogeneity. If those issues are not there, then we know theoretically, we know that is fine. We can now go ahead and make some bit of prediction. Although I've said that recursive models are inconsistent, in most cases they are inconsistent. When you are making a policy, when you are deriving a policy, if the predictor variable, for example, if you look at education vis-a-vis the earnings, I'm sure even up to now, it is taking time to convince people why they should continue valuing education. Some people no longer want to value education because they have seen at times people earning a lot more than even educated one. So I think when you're making such kind of modeling, you need to bring out those instrumental variables to strengthen the discussion, the conclusion, and the policy. Otherwise, it may not sound to be obvious. Chair, allow me to stop here. I think for today. Over to you, Chair.
All right. Thank you very much, Dr. Gideon, for that elaborate discussion on recursive and non-recursive models, and also unpacking the concept of endogeneity and how to deal with endogenous bias. So we appreciate you and we thank you. I think we can go into the question and answer sessions. I'm seeing time is running, and then senior colleague may come in at that point to make their specific additions on what you have just mentioned. So as you answer these questions, we can possibly also wait for the senior colleagues to give in. Those who can give in something, they can really come in and contribute. There is I think the one for Alima Zubair was for the first session. That will be talked about later. Kindly give more insights on more modern theory. That was for the first session. Kalinzi, yes, we have used random figures. I think Professor has given a response. Then Sylvia. Sylvia is saying, thank you, Dr. Gideon, for the wonderful presentation. My concern is on how can one identify a good IV. Secondly, what options are available for addressing endogeneity bias where one fails to get a good IV or it is weak? Thirdly, is it fatal if one ignores a bidirectional feedback loop relationship? Is it fatal? I think that is a very important question. Is it fatal if one ignores a bidirectional feedback loop relationship? And then question number 2, we can take these two at once. It's coming from Tushabe Peace. Thank you so much, Dr. Gideon, for those wonderful insights. A concern, we retrieve variables from theories. If I find endogenous bias, do I need to drop the theory or I go back to the particular theory and do more analysis? And what brings it yet I picked those variables in the theory? Okay. I assume it is an instrumental variable. I think question 2, Professor may come in and give support here. And Dr. Gideon, yes, there is a question from, I think we can take those 2, then I'll go back to Dorcas. Dorcas's hand is up, I'll look at it later. Can you answer, Sylvia?
Yes, Chair.
Yes, I was saying,
Yes, please.
that we can hand over to Shabe and Sylvia, and then we can go to others later.
Okay, thank you, thank you. I think let me start with Sylvia's concern, how to identify a good IV. One, identifying of good IV. You know, when you are theorizing, when you theorize, if you read the theory very well, you may get metaphors to explain exactly what is happening. Now, as you understand the metaphors, then you are able to come up with the construct. Now, why do we call it a good IV? A good IV is one that is helping you to explain the problem, your DV. And a good IV, to me, is the one which can be measured. You know, you can't study what can be measured. So if you, one, theoretically, you are able to extract a variable, and then two, you are able to personalize it and measure it. Measuring it is at different levels. You remember when you have personalized it, the question is, are you even adapting items from previous studies? When you adapt, what does it mean? You need to check whether the instrument was able to actually measure what you have extracted by looking at exploratory factor analysis and confirmatory factor analysis. The good thing when you go to confirmatory factor analysis, you are able to come up with the measurement models, the measurement model for that variable. Meaning that at that point, if your operationalization was weak and most of the item collapse and you remain with one item, two items even dangerous, definitely at that level, you are able to see whether actually that variable is measured well, or whether it is explaining exactly your construct which you earlier had by the time you are theorizing. So to me, for us to say a good variable, one, it is the one that is explaining your DV, and then two, it can be operationalized well, and it can actually be measured, in other words, following the number of steps I've mentioned. Now, when we say endogeneity, what is our concern? Our concern that even if that DV, I mean that IV, is able to explain the other one, there could be something that you left out which can actually improve it. In other words, as you understand the context and the review of literature, because every day knowledge is being generated, there could be something that you left out, which perhaps in your you could have captured it in the data set, but you did not pay attention to it. But when you regress it, you find it is actually fulfilling the characteristics of the instrumental variable. So for me, it's not an option for you not to address the endogeneity issues. It is actually a must. For me, that's what I can say. Because you could have operations well, but again, there's something you left out. And leaving it out, you are going to come up possibly for the country. Please, I think for me, don't take it light. Is it fatal? If one ignores a bidirectional, this depends on the context and what is happening exactly. I've told you today, if you correlate education with the earnings of people and you ignore the instrumental variables, for sure, you may not easily convince most people to pay fees. Some people think that it is the other way around, that perhaps let me first make money. After making money, I go and study. After all, education may not necessarily be free. And again, at the same time, we are saying, can you study? After studying, we expect you to earn more. Now, why do you find that argument in people's perception? That means when you are doing such kind of studies, you need, I may say, it is bringing that by direction, the feedback loop, which you can't ignore. Look for the instrumental variable to handle that. The other one I think is peace. Let me look at that. The concern, you retrieve variables from theories. You are saying if you find endogenous developed theory. Here I'm saying theorization could have been fine, but during analysis, did you pay attention to endogeneity issues? One, we can't hide in theorizing. Theorizing without bringing out the insights in operationalization and measurement of variables, knowing the current debate where you are contributing, ignoring that, then later it may cause an issue again when it comes to handling the bias. So for me, it's not an issue of dropping the theory. The theory could have been fine, but when it comes to the instrument, questionnaire design, you could have ignored some of these things as well. I think, Chair, that is what the two comments.
Thank you very much. There's some other submission done by Ewaju, please, can you remove your screen? Okay. Some other submission done by our student economist, Mr. Bernard Wabukala, in the chat room. And I will request him to unmute and add his voice. Then I invite Lucas and Ewaju. Bernard?
Yes, Chair. I thought I had maybe said that in the interest of time, but I was just trying to restate in a way what Dr. Nkurunziza has talked about. I think the first step is what is endogeneity itself. What does it mean? How does it manifest? And of course, the first issue is to understand its definition, or when does endogeneity arise? So theoretically, or from what you have conceptualized, I'm just going to try to repeat that you state that X influences or predicts Y. But theoretically, you establish that X on its own is not actually predicting Y or influencing Y. Rather, there is some unseen characteristic or call it another variable Z, which influences X, and then that makes that X to be a predictor of Y. So if we have such a scenario, and there are some examples in literature and arguments that may lead to such a case. And so in that case, you'll have what Dr. Nkurunziza has explained as endogeneity problem. There is some influence of X to Y, but not on its own because of some other unidentified or unseen characteristic Z, which influences Y. Now, Z does not have direct influence on Y. It can only be explained through X. So if we have such a case, instead of saying X influences or predicts Y, you are bringing in the influence of Z. It has a relationship with X, but it does not have a relationship with Y. So it goes through X. That makes the X now to predict Y, but not X on its own. If you have such an argument or occurrence, that is what we call bi-endogeneity. So you don't drop the theory, you don't drop the variable, you handle such a relationship through what Dr. Nkurunziza has told us. So there are steps to do that. Z might not be alone. In fact, there might be 5 or 4 variables that might be influencing X. All those are potential candidates for an instrumental variable. You have to only play around or check the relationship, find the strongest. We use instruments can either be weak or strong. Sylvia has mentioned that. So if you have 3 variables that are influencing X and you don't know which one, but of course it has to come from a theoretical background. It's not everything around the X that must be assembled as an instrument. So you check for the relationships and see which one is a strong instrument, and then you use that one as your instrumental variable in that relationship. Yeah, that's what I can say for now.
Thank you very much, Bernard. Then Dorcas, then after Dorcas, Julius.
Thank you, Chair. I just had 2 concerns. Dr. Nkurunziza, may I please know if there is a situation where we can have a partial recursive effect, and under what circumstances can this happen? Thank you.
Good. Doctor, have you captured that?
Yes, you have captured.
Then Julius.
Thank you. Thank you. My name is Ewaji Julius. First, I would want to thank Professor and particularly Dr. Gideon for your very good presentation. Now, my question is that in the matter that endogeneity can affect the reliability and the generalizability of results when you are conducting research, are there some ways, and if they are there, what are those ways that you can use to be able to handle endogeneity when you are conducting analysis during research in chapter 4? I wanted just to pray, Doctor, that you help us bring this out clearly. The ways that you can use to handle endogeneity during analysis, so that the generalizability of results is not grossly affected, and the research can be accepted. Thank you very much.
Okay, welcome and thank you, Julius. Dr. Gideon, you can answer those 2. And then we look for the senior colleagues and we close.
Okay, thank you very much, Chair. Bernard, thank you for more insights you have shared. I start with the Julius. Julius, I believe our emphasis has been on 2-stage least square method, of how to handle the endogeneity from statistical perspective. The other procedure issues I mentioned, you need to be mindful of the measurement errors. One, I've said that sometimes these measurement errors may be inherent, but you must find out how to minimize them. One way, even the choice of statistical analysis that you are going to, statistical package that you are going to use matters. You have had cases where people say your sample is very small. Why did you use the Amos when your sample is brought 200? Why do you go by smart PRS? It is to minimize those errors, measurement errors. Because with the smart PRS, it will give you the predicted values. You don't go into measurement errors. The suspicion is not there. That is one way. The other one, of course, as you operationalize the measures, don't take it light. Be sure about the operationalization and measurement. Don't take it light. You can even go further to look at what was the CVI. What was the validity index Cronbach for the previous studies that measured the same variable. And you have a stronger debate on that so that you don't have those unnecessary issues. The other one is about, of course, specifying the model. When you are specifying the model, especially during the analysis, you need to pay attention to the instrumental variables again. I think basically maybe we may have one-on-one more discussion on that since time may not be enough for us now to elaborate
Thank you,
more.
Thank you.
However, for I think Madame Karema was talking about partial recursive effects. Yeah, the partial recursive effects may come in. And this is one of the situations that sometimes very tricky to handle. You may find that there is no feedback loops. There is no feedback loops. Those ones are not there. It's not there. It's not an issue. But when you look at critically the errors, how the error term for the predictor variable, maybe one of predictor variables or more than one of predictor variables with the response variable, you find they are correlated. And that happens when you are using Amos and you're looking at structure-driven model. In most cases, people don't pay attention to that. At times you have the partial recursive model. Just paying attention to the error terms. I think that perspective. Maybe that's what can add on. Chair, submit.
Thank you very much. I just wanted to call upon the senior colleagues, if there's anybody who can give one more advice to the students regarding managing endogeneity is concerned, can come in and then give that advice. Then we shall end with Professor Michael Koche, who will come and give the closing remarks. Just to mention that Professor Okoche is also organizing a conference in December. Students who may wish to participate and also present their work in the conference, it has a mileage on their side. It has a benefit on their side. So please take note of that, and Professor Mike will really will welcome you. Let me call upon our senior mentor to give some comments on this. Professor Antai.
Chair, thank you very much. And thank you very much, Gideon, for your presentation. Chair, I really do not have much to say at the moment, but just to respond to a few things, like somebody asked a question as to whether it is really fatal to not really to consider this element of endogeneity or probably the presence of it and so forth. I posted an article in the chat room, and that article is endogeneity, how failure to correct for it can cause wrong inferences and some remedies. It's from the British Journal of Management, volume 26, and it's a 2015 paper. If you need more information and probably on this and giving you books, I can also provide. So endogeneity is a serious thing that you need to consider in your studies, and please test for it and handle it. Do not simply leave it hanging. And probably to respond to the, are you hearing me?
Yes, Prof, we are hearing you.
Okay, I was getting worried. I think there's another student who was saying, you know, we pick these things from theories. You know, I've always heard these statements from students, and I've always challenged the students just for me to demonstrate that they actually understand these theories and they have read the theories. And in fact, even the students who mix 5 theories or 6 theories and 3 theories or so, they have not read them. They don't understand these theories. So what they have done is actually to pick rumors about these theories. And how do they pick rumors? When they meet their friends, they say, well, for me, I've used resource-based theory. For me, I've used complexity. I've used this and the other. But they have never picked a book on complexity theory, which has about 500 pages, and read that book from cover to cover and understand the theory. So what you see is a summary, one strength, one weakness, and so forth. And they say, now we bring in the second theory to explain this, right? And when you see what they bring in as in second theory to explain, actually, that particular aspect is covered by the same or the previous theory that the fellow has dismissed, right? But because they have failed to understand, and sometimes they even bring what we call local theories to supplement mid-range theories, or even to supplement grand theories, which can be very, well, it can be okay, but when you look at the circumstances and the context, they're actually telling lies in most cases. So anyway, for me, I can say, try to read those theories and understand them very well, so that when you start using metaphors, you are very close to what the theory actually says, rather than just jumping around with what your colleagues tell you. Endogeneity is a real issue, and please attempt to test for it. Don't use, you know, in the past, some of the students have come up with innovative ways of handling endogeneity. They will say, no, bring in control variables, do this and this and the other. And we have crammed those things over the years incidentally. And most students keep on recycling and regurgitating the same things because they don't want to read. They are very lazy. And that's why sometimes when you look at some section, like the methodology section of one student who has submitted a PhD and another one, you find the same things. Now everybody's singing critical realism. When they start mixing qualitative and quantitative, they say critical realism, but ask the fellow what the whole thing means. The fellow doesn't understand. Maybe that's what I can say. Ahmad, over to you.
Thank you very much, Professor, for emphasizing the issue of theory and why we need to read as much as possible before really the level of conceptualization. So Professor is just emphasizing that some of these challenges emanate from our inability to take conceptualization and reading theories well. Right. Anyone more comment from the senior colleagues? Dr. Msenze, any comment of Professor Arola?
Thank you, moderator.
Thank you, Prof.
Actually, a lot has already been said, and I don't want to dilute that, but I just want to add my voice to what Professor Ntai ended with. There is a tendency of just cramming and thinking that whatever is in the other book must also be in your book. This I've always emphasized here. Let us get into the reading culture and understand these things. And this thing of saying, I picked this variable from this theory, I picked this variable from this theory. I hope people understood from the session in the morning. Theories are there to explain a relationship. That is something that has always been emphasized here, but there's still a problem. So take Professor Ntai's call very seriously. Otherwise, Gideon, thank you for the job well done. I too also learned a few things, and I'm grateful. Learning continues. Thank you. Over to you, Chair.
Thank you, Professor. Allow me to invite Dr. Professor Michael Koche to come and sum up the session and also give a prayer so that we can go and do other things and then prepare for next week. Professor Michael?
Okay, thank you, Dr. Hamad Algimbe, for moderating the session. Thank you for the job well done. You have done a good job to make sure that we go through this process this morning. I also want to thank our mentor, Professor Joseph Ntai. Honestly, Professor, if you reflect, and all of us who are in the call, if you reflect from the time of we started, look at the level of growth, look at the level different people have been able to present. Me, I reflect on my personal self, and then also I look at some of the students' work which was presented sometime from the start, and if you look at even some are now able to hold very interesting presentation, which all of us are learning. I think, Professor, we must thank you honestly. And you are like a big tree where all other people derive a refuge. So, Professor, thank you so much. I also want to appreciate all the senior colleagues. Senior colleagues, thank you so much. Different people have been able to present. The small contributions you make really impact on different people differently. I also want to appreciate everyone who has logged in. And I think we're now a family of the Socrates. I think it is very important that we try as much as possible to log in. You could be knowing already the topic which is going to be presented, but learning continues. And sometimes hearing for the second time helps us to confirm that what you know is true. It is a point of really greatness. Dr. Gideon, thank you so much. You have done a very wonderful job. Thank you so much. Thank you so much. And I know that through your presentation, some problem which has been bothering somebody has been sorted out, but also it provokes people to go further, and also it opens another avenue for people to reflect. So, Dr. Gideon, thank you. But also what I want to say is that this platform really has a diversity of people with great competences in different areas. Qualitative data analysis, I remember we had, I think, 4 or 5 sessions. And you'll see, so you clearly see that even as students, that as you keep on logging, you'll be able to get the best from the best, really. So I believe that I just want to make a small comment about the presentation, and also in line with what Professor Joseph Ntai and Professor Laura highlighted. Actually, if you get the conceptualization wrong, and of course the conceptualization eventually is what determines eventually which methodology you are going to use. It is very difficult for you to say that is there a way you can fix it. And I think there's a big challenge most times where people believe that you get just so crazy about analysis without knowing how we got there. So the theories of statistics also are very important, but also the theories of the knowledge which you are trying to create is a very critical issue. So as we learn how to do modeling, we must also be sure that the dimensions which are going to help you to come up with eventually the model, which was basically a conceptual model, which eventually they are going to confirm whether it is true or false, or is very critical that you really. That's why I think, so all these sessions are very important, and I think we take those things seriously. And instead of us thinking that, is there a way we can, would it be fatal? I think for me, if I was to give an answer, it can be fatal if we don't properly. And the good thing, and I think there's a one time Professor Joseph Ntai was making a presentation and was basically answering somebody that is not, we try to domesticate a snake and think that will not harm you. That's actually what will happen. So as we try to bring concepts, let us try to make sure that the concepts are very firm, are very sound theoretically. Okay, finally, I must say that it is really wonderful to wake up every morning for us. Let us make it our religion that every morning we come together, congregate in this Zoom meeting, and then we advance scholarship. I think at this juncture, I want us to humble ourselves and pray as we end the day. Again, thank you, Dr. Olgembe, and all of us for making sure that they come to this this moment. But there's something very interesting. I think, which I think we shall maybe discuss at some point. I think we normally meet through Zoom, and maybe one time through the organizers we could meet one time physical also on some issues. Okay, let us pray. Heavenly Father, I want to thank you so much for this morning. I want to thank you for the presenter and the moderator and our senior mentor, Professor Joseph Ntai, and everyone who logged in. Father, we thank you that this is an avenue where all of us come to learn, where we come to share our knowledge. And we thank you for the provision of this platform. And also we thank you for all the people who are giving into the cause of advancing knowledge and for the well-being of each of us. Father, I also want to thank you for this day. We want to thank you for the coming week. We want to thank you for all our endeavors. We pray that, Lord, you continue protecting us, you continue guiding us, and that, Lord, as we start this week and we start this day, be with us. We thank you. We pray all this through Christ our Lord. Amen.
Amen.
Amen. Thank you.
Thank you very much, members. Thank you, all of you, for being with us today. May God bless you, and we meet next week.
Thank you very much, Chair, and goodbye to everyone.
Goodbye, Professor.
Goodbye, everyone. Thank you, Professor.